Okay, great. As you all know, it's being recorded. Sharing your video is awesome. I appreciate it, but not required. So I want to walk us through the hypothetical life cycle impact assessment exercise. Now, before I get too far into it, I really want to emphasize the hypothetical part of this. Right? The reason this is hypothetical is that a real life cycle impact assessment is very hard to do. It can be on the order of magnitude of an entire PhD. It can be a full-time job at an engineering company. It could be a full-time job as part of a team of 10 people at an engineering company. And you often use software that costs on the order of $20,000, $30,000 to help you do these kind of things. One of the reasons is because there's such a variety in the assessment of the ecosystem impacts of each of these stages. And there's such a variety in the materials you can pick and choose. And if one of you are really interested in digging into this more, please reach out and I can help point you to some other resources that are great. What I have done is try to come up with a constrained set of materials you're allowed to use and my sort of informed judgment about their environmental impacts. So I have some sources that I've leveraged and then I've built from that sort of my expert opinion, and those are the numbers we use in here. So the numbers in here are hypothetical. They're relatively correct, but they're not meaningful enough that you should ever use this in a real exercise. If you're going to do a real life cycle assessment, whether it's for school or for work or whatever, you really should invest in the proper tools to help you do this. This is just to help us understand the process, the way of thinking, how you get different results, and how you might compare those results. The other thing you'll note here is that it says team name and team members. If you're in the online class or if we're doing remote instruction, we're going to do this as an individual exercise. If you really want to do it as a team, please reach out to me and discuss, sort of give me your proposal of team members and what your process is going to look like. And I may or may not say, sure, thumbs up or thumbs down. I think it's a in-depth enough exercise, and it's a little bit challenging right now, especially during remote instruction, to coordinate. And so I think this single individual exercise is the way to go. You'll see here, I very much in bold, the data below is not accurate, right? And that's okay. We can learn a lot, even if the number isn't exactly right. So what are we going to do, right? We are going to be given a set of constrained materials. And then you are going to think about how you're going to put together two different products from this constrained list of materials. Okay? So the materials that we have here are aluminum sheet aluminum, steel sheet steel, wood, glass, cotton cloth, leather, and synthetic leather. Those are our 7 materials that you can use. And you might at first glance be like, what do I make from those 7 materials, right? Turns out you can make a lot. I've seen a ton of really cool, great ideas, okay? Now, the guideline is you're 2 different products. They don't need to be competing products or anything like that. They can be completely different products, completely unrelated. Need to be these 7 materials must constitute 95% of the total mass. Okay? So I'm giving you 5% of the total mass as a freebie. I'm saying in that 5%, go ahead, you can have some glue, you can have some nails, you can have some screws, kind of little itty bitty things that you need to kind of finish off the product, but it's got to be less than 5% of the total mass of the product. So if something weighs 100 grams, you have 5 grams that can be stuff that's not on this list. The 95 grams has to come from this list of 7 things. Now, we have 2 different products. Try to come up with 2 different products that are of similar total mass. If you can't do that, don't stress out, okay? Because if you can't do that, then you have to just use this thing called the functional unit, which hopefully you've read in Tom Thies's book, but I'll describe it here, okay? So if you can do similar mass, great. If not, just make sure you know that the functional unit is something you need to worry about. Do not pick beverage containers. The number of LCIAs that have been done on beverage containers is in the hundreds. Don't bother doing it, okay? Pick relatively simple stuff, not overly complex, no electronic stuff, nothing really powered, I think that just complicates everything, right? So nothing that should get plugged in, etc. Do all your work on scratch paper. This includes your ideas brainstorming, your drawings of products, your masses of the various materials, how they will work in your product, etc. All that scratch work should come in and be part of your submission, right? So if you do it all handwritten, whatever, that's super cool. Take pictures, embed that into a larger document that'll be the report that you submit. Okay, there's some tables that need to be included, okay? You will recreate these tables in whatever document you have. You build them however you want, just make them in whatever document you have. You'll notice that there's a product A, product B. You need to describe what it is. So what is the product name? What is the product name? And product A is in this row, product B is in this row. Right? What is this function? What does the product do? Yeah. Where do you think your materials are going to come from? There's a great, tons of great resources online to figure out where materials are sourced. The US Geological Survey also has a great handbook on where materials tend to come from. And try to understand a little bit about that extraction and manufacturing process. Right? Like, how do I make steel? Where does it come from? As an engineer, you should at least have like a very surface understanding of that. Right? Then, what is the total mass of your product? And this one's kind of an interesting one. Like, what is the total transportation distance that's going to be required here? Because it turns out, as hopefully you've read in the sustainability module, there is this global supply chain that has a transportation impact that is important. So what is the total transportation distance from manufacturing to user? Once you've gotten that table done, then things get more interesting. You're going to make another table which focuses on each of those 7 materials we talked about. Those 7 materials are the aluminum, the steel, the wood, the glass, the cotton cloth, the leather, and the synthetic leather. And in product A, how many grams are there, right? So this might be 15 grams, and this might be 2,000 grams, and this might be 0 grams. You don't have to use everything, okay? And then product B might be a little bit different. Product B might be 2,000 grams of wood and 15 grams of glass, and then everything else is 0. So the most interesting results will come if you have a variety of materials being used. If product A and product B are extremely similar, the results are not going to be interesting. And so if product A and product B are made of almost similar materials, exactly the same quantities, the results are less interesting. So get a little diverse with your solution, and I think you'll have more interesting results. Then the next thing I want you to make sure you talk about is, why did you choose that material? What is the role of that material in my product? So maybe steel, this is like structural. This is look pretty. And this is shorthand. I would expect that you write much nicer and more detailed and in complete sentences. But maybe the steel plays a structural role. Here, the aluminum makes it pretty. And maybe in the wood, in the product B, the wood is structural and the glass makes it look pretty. So I haven't even defined what this thing is, but I'm just trying to get you to think about, okay, how will these materials work? What are the roles in the product, etc. Remember, you still have that 5%. You can do something else with the 5%, but we're just going to focus on the 95 and the 7 materials here. You do not need to use all 7 materials, and try to make sure your materials are a good mix across the 2. Finally, there are 2 questions that I want you to give me a short paragraph on. One is, estimate via your own educated guess. So based on what you may sort of know or heard about in your readings, maybe you read it in the sustainability module, or maybe you just heard it from somebody. So via educated guess, which of these products will have a less harmful overall life cycle impact to sea? And explain why you think that is. Yeah. Explain why you think that is. So that is my introduction to, that is my introduction to the LCIA. I didn't mean to stop sharing, but we'll go ahead and stop sharing.
I have a question. Sorry.
Oh, hold on.